3D printing has been there for a long time, very, very long time, even before you're all born. 33 years or more. It was invented in 93. In fact, 90s. Any technology for that matter. They always begin long, long time ago. But adoption became very uh, delayed. And 3D printing is really delayed because people are not able to find uh, how it's going to change their lives. That's very important for any technology. Suppose it is not changing your life, then it becomes people don't see the person to value. So 3D printing, first of all, let us learn what is printing. What is printing? Printing is nothing but reproduction of text and images. Correct? But the dictionary definition of what is 3D printing. And 3D printing is same with additional thing, that is object. So 3D printing is a process of reproducing text, images, and objects. Objects you can actually hold and explore, right? And it's very important how I like to manage my signal.
It is visible, visible.
You can see the screen, right? Yes, right. Now I wanted to see myself also, as so I'm trying to adjust. So 3D printing. Many people call it as additive manufacturing. Somehow I'm not for it because various reasons I will just now. Why I don't like this terminology. So in the nature, everything is additively manufactured. Everything is almost anything you see, they are made by additively created, like human beings. We are all additive. Just 9 months we are created. So we have a team inside, which is very strong. Outside muscles are soft. We have bionic camera, his eyes, bionic microphone,
Bionic camera, bionic
CPU,
microphone.
brain, all this. So, what are in nature? What are made? For example, when a seed is put, you get to see it grow into a small shoot, herb, shrub, and tree, whatever you call it. They all keep on growing. This growing is nothing but activity. Right? You take the example of a nariyal. Nariyal is made up of so many layers. Inside, rubbery, soft, shell is strong, very strong, and outside fibrous. And onion, kanda mein, you have layers. Cut it, you can see the layers. And you cut a tree, for example, you see the annual leaves there. They're all showing that what is the age of the tree.
Layer.
So every layer tells you that. Moti, moti is also a small inclusion that is in the muscle, the mother of pearl, and that's get deposited with calcium coatings, calcium on the cells, and beautiful, this beautiful creation called pearl, right? And in fact, in our own kitchen, there are a lot of things. जो चकली बनाते हैं is like this. We use a instrument where we extrude.
Chakli.
It's also additively made. And jalebi banana, where we additively made. And then you have sabudana, fried sesame.
Array, sabudana.
And they also come in colors. They're all additively made. What else is that?
Laddu.
too is additive. So beautiful. Hope you had nice food. It's and then there are other things, like for example, plywood. Plywood is also made from additive. You take a peel of wood, stick with another peel, and create things. That's what plywood is all about. And you have mehendi. Mehendi is also something thick. You're able to draw it on hand, get a beautiful designs which are preserved, right? And how is that? That is also an activity. Brick by brick, the buildings are built, and this is also additive. So additive is not only 3D printing. So 3D printing is a subset of additive, and that's what I want. So when we say additive, is there anything called substitutive? Yes, of course. A lot of substitutes. For example, again going back to kitchen, nariyal को हम grating करते हैं. So you can see using this grater, grating nariyal. And same way, murtikar. You take a small chips of stone, and murti bana. In fact, beautiful sculptures all over the world. This is Michelangelo's David. It is researched world over, seeing the perfect form. How people, those artists, knew about the anatomy, human anatomy. It's a great sculpture, this proportion, because not only life size, it's beyond life size. So these people had such a great control over the proportion and mastery over not only tone but finishing without actually losing any bit of extra stroke as required. And you can see so the more sculpture very nice. It's hard to believe it is stone. कैसे बनाए हो long with the web. So in order to achieve this, our mastery. So these are all subtract. Our own Indian example, we have Gomateshwara in Shivanapedagura, which is also a 57 feet monolithic stone sculpture. Somewhere some 13, 14,000 years ago, it was done in the 11th century, 10th century. And, so coming to the context, why are we talking about this? In fact, the human race, so-called manufacturing was not there before, long time ago, about 200 million years ago. No term called manufacturing. People were all doing some kind of craft. The only option was more, it was not more. Even it was more, people had a lot of craftsmen who used to craft it. And they say, I remember my grandmother used to do some things, cap or sweater. Even today, some grandmas may do, I don't know. Time is changing now. But it used to be like that. People used to create a lot of things, handcraft. And in fact, handcrafting developed into a guild system. And even today, Dota banate is they may is still there. It's handcrafted. What else is handcrafted? It's called handcrafted. This is again handcrafted. So you don't get thousands of one type of basket because it is never made in a mass production. It's never made in a factory. So what you see here are different varieties, but nothing more than one or two or three you find. Okay, only those which are normally used and consumed, they make more and then came the industrial one wherein people had lot of machinery came in. Hand skills were not sufficient to produce more. So the capability to increase that, they people started working on machines and steam power came, and you can see this a sweater making factory. still not mechanized, but you can see the look and feel of factory has come. The supervisor, raw material put in the center, they're all picking up, they're doing somebody inspects. Kind of a idea factory was born from them in the 18th century. And then came the industrial revolutions. A very bad scene is the pollution. Everywhere, people produced a lot of material and also they polluted the air, polluted health.
That's the
It
level.
all got messed up because of industrial revolution. It's a very typical scene of progress of what. Of course, with electricity, people started, even with steam engines, people had lathe and steam engine lathe. So every machining started. Then came the Ford's car making and this machining is a lot of chips. The chips you cannot eat, and the revolution 2 brought in the Ford, the line production system. Okay, wherein people had a chassis which is entering on the side. It goes out as a finished car after you put the four wheels and it moves out of the factory as a finished car. You just see how people are lined up, each one doing a bit of work and goes on and to make the entire car. So this Ford company USA from Tempo again, then came Industrial Revolution 3, wherein many things like the radio, came, radios, only on valves. So I used to have a lot of valves, play with the valves earlier. The valves gave way to transistors, which were very small and small. The transistors then gave way to ICs. Then all the 10 ICs gave rise to the processors, microprocessors and all. So what you see on screen is a first electromechanical calculator, which was occupying the entire. What it will do is just add 1 plus 1 is equal. But today, you all hold in hand. Not even you hold it a calculator now, a smartphone where you have a app, calc app you use it. This was the scene long time ago in the 50s. Then, of course, it led to automation, robotics, IT, all these things. Today, we are entering into a new, yet another regime, which is called cyber physical system or industry 4.0. I'm not scaring all of you, but it is a new order wherein not many people are required to remember. Few people, because everything is automated. Things like IoT, blockchain, autonomous robots, all of them, they are there to disrupt manufacturing. So, 3D printing, coming back to our subject today, let us see something about invention. This is the guy who first discovered it. See his small apparatus and what he made. And of course, what he did was he exposed a photopolymer to light. When photopolymer is exposed to light, light falls at a particular frequency, it will solidify. It is something like how a salt water, gets crystalline with the treatment of sun rays. But this here it happens very fast
Photopolymer.
because sun rays, their frequency is UV is there, but probably the energy is less. They are taking more energy. So monomer taking a energy H2 becomes a polymer. With cross linkage, it becomes a crystalline salt. That is the basis. And of course, you have so many pioneers who started it all. Dr. Budama was the guy who first proposed it. Chuckle, he is called as the father of 3D printing,
Father of
and
3D
called
printing, Chuck
Decoy,
Hull.
he came out with another technology called SLS. Likewise, it goes on. And you have FDR and have some more people. In fact, it is Emmanuel Search. He was from MIT. He gave the name 3D printing. This technology,
Human such
and
is 3D
it
printing.
was really nice that he gave away to the world the name 3D printing, which he was keeping it as a trade secret or trademark. Correct. And move on. Many people, even today, because there are so many different versions of 3D printing, people wonder what is 3D printing. There can be a confusion. People who know FDM, they think FDM is 3D. If people know SLS, they think SLS is 3D. SLA, the one which was first discovered, stereolithography. Some people think that is 3D. In a way, they're all right. They're all looking at the same elephant called 3D printing, and they have different names because they work differently. Okay. And so that takes us to the definition. So 3D printing is a set of technologies which help us to fabricate objects layer upon layer by a digital input data. What can be the digital input data? It can be a computer model, like what your Professor Anmol is teaching you, how to create a entity, virtual entity on a computer. And then, of course, you have people can scan it, scan, take a scan data that is also digital. And in the medical imaging, you have CT scan, MRI, echo, all these modalities. Even they are all sliced data. And if they are stacked in a sequence, they also give a volume which can be used for therapy. So these are all input to so you can see here a 3D model is very important, and a slicing software is used to slice it, and these slices are given to a robot. That robot we call it as 3D printer. Okay. What that robot will do, it will put one at a time, one layer it will finish, one slice it will print. And when these slices are stacked in a particular order, same sequence, you get the object which you can hold in hand and explain. So that is the basic funda of 3D printing. You can see it here, FDR, or the heated head keeps on drawing the things,
FDM.
and here the table Z will keep on going down as it prints. So this is just information. So, then came Dr. Adrien and all. They proposed a printer can print itself. So much so, a lot of people drew such a cartoon, which was showing that it is not impossible, but it is not really directly possible. Some components of the printer can be printed. That's what it means. And in fact, a 3D printer need not be looking like a box. Even a cooker robot with a clay injection kind of thing, you have that dispenser depositing clay there, it can do the as good job as a 3D printer. So, in fact, this is a 3D. This can also be called as a 3D printer because it is taking digital data, and it is converting the object. And 3D rulers have come. This is very analogous to one of the 3D printing process called FDR, and the filament is taken in and it is heated at the tip and it is deposited just like a toothpaste paste. If it is taken out for wind and for heat, it will dry and it will continue. That's what happens with this. And many people wonder this is a 3D printer, and they argue it's a 3D printer. So I'll say no, this is not a 3D printer, though it looks like a 3D printer because there is no digital input into this. Because you're holding in hand and you're drawing yourself, and data comes from your head, whatever you want to do. You don't know what you want to do. You want to draw your name, you want to draw a house. Let's see how it works. You can see here, the hot tip, you can make this. And so it is all hand skill how we can do this. So this is not a 3D printer. though it works on the 3D printing principle, a 3D ruler is not a 3D printer. You see this. This yet another same kind of printer. It's called Delta. You can see how it's printed.
Delta
They've got
printer.
a totally different kind of printer head. We call it a spider sometimes. It is very much different from what we saw earlier. Well, there are more technologies. This is band photopolymerization, SLA. And SLA also comes in small desktop things like this. You also have selective laser sintering. The machine look like this. You can see the part it makes. In fact, SLAs is one of the best form of 3D printer one can have because you can do impossible. Yes, you heard right. You can create impossibles here. Like what? Like things which are assembled, pre-assembled. You can make a chain, for example. You can make a cloth, for example. You can make a spectacle, for example. Well, things which are pre-assembled. And these are some of the desktop versions of the machine. And this is FDM. FDM we saw some time back. Here you see this is the big one. It's a small one. This costs about crore plus. This costs about a lakh. Both of them give the same path. That means FDM as a technology, came to become the open source. Because of that, technology has become cheaper. And you and me can do it. We can download it from Google and build our own 3D printer. This technology, because patent is expired and all, and a lot of people will help you to do it. It's an amateur kind of thing. I used to be a ham radio operator, so sometime back we used to make our own radio. Not only we make radio, we also talk to each other across the globe. So I still have a HF set, 2 meters set with me, by which we converse. So you sit at home and no internet at all. We used to have an antenna, a cheap plane antenna. Fun. It's the same science and technology, propagation of radio. So the same way, there is a big community which are interested in making things, like called makers. So 3D printer of this kind, the fused deposition modeling or material extrusion has become a kind of maker community technology. And well, so being cheaper, you can also buy it. It's about 10,000 rupees. You can see what you can do with a small printer like that. You can do big things. This memo is made by that kind of thing. So you also get a lot of that commercially. You have so many of them, and you have another technology called laminated object manufacturing. It was discovered in 92, 95. The company closed its doors. They became bankrupt. So technology is sometimes though good, not everyone becomes successful. Nokia was a great phone, but still Apple and Samsung we, they became one. Sometimes they fight for the position. Apple still is the help. So this technology did not, was not adopted. Recently, Ireland company started making it using A4 paper and all, but we even got shut down. This is yet another technology where material jetting, polyjet or multijet it's called. The beauty of this technology is that you can have a part, which is having transparent to opaque, and you have hard to soft, just like your hand. It can have a soft outside, it can have a hard hardly inside. So you can see in the middle of the slide that there is a part which has got a switch which is soft to touch but hard inside. The manifold, which is gray, lighter gray, is very strong, and you can see a small ring at the top. That ring is a gasket actually, and that will be very soft. So it's all printed in one go. So in future there is a capability to print such things. That means if even the metal or conductive inks can be worked, we can actually have uh, products embedded with electronics also and intelligence also. It's also system. And moving forward, then we come to metal. Metal, of course, has a different story. Metal has been there for almost 100 plus years. The way people deposit metal and make artifacts is always there. Weld, by welding. Even today, welding was the mother of metal 3D. So today, lot of new technologies have come in metallurgy. They're very costly as of now, but they're all becoming uh, available as open source very soon, thanks to the patents which are getting expired. As they get expired, the technology the cost will not be there. So people can uh, start fabricating each one on their own. And of course, few companies will start getting into greater research. Of course, the inventors, whoever have companies, they continue to do R&D, and the overall cost of the technology will come down. It will become more affordable. Like what you have smartphone. If you take smartphone, you have iPhone, which is a premium phone, but you also have many smartphones available today, which have color, they have got camera, and they do almost 80-90% of iPhone also. They do. So I think this is something which is very good. Yesterday was the industrial world, you know, industrial design world day yesterday. There was a discussion how students who cannot afford how they will join virtual classroom and all. So someone was making a reference that smartphones have become now accessible, and you have apps connect to anything, any platform, Zoom or Microsoft Meet, Google Meet, etc. So I think that way it's going to be accessible. So the same refers to even these printers. They will also become more. You can see here metal 3D printing. There is also animation, but I think it's not working. Don't worry. So this just goes round. So this is a laser mark which is coming, and you can see after effect how it is glowing, but it sinters a metal powder. And one layer is done this way, and one more layer of powder is spread after this. Again, the scanning happens, and this continues to give you a metal part. So today, aerospace parts are done, automotive parts are done, jewelry is done, medical parts are done. Many. You can see these are some of the metal printers. So big, huge, like a room. And this is a sand printer. They'll make sand mounds and all for casting. And this is a street printer where you have chocolate printer where chocolates deposited. You can have a cake which can be decorated by your name. And coming to applications, there are huge area. So today, 3D printing is making a huge impact on different sectors, jewelry, medical, FMC packaging, lifestyle, architecture, automotive, aerospace, electronics, electrical, white goods, plastics, gifting, Hollywood, and it goes on. So it's very important. The technology when it entered, it was not capable of doing everything. People could only make some dumb models like this, what you see here. There is no screen,
Dumb model.
buttons cannot be pressed, and inside we can see nothing. But today, it gave rise to a lot of functional products. Functional products which are testable. You can fix it on a vehicle, test it out, all that. That's where we are heading. And any technology, industry have to adopt it. Otherwise, they'll be left out. And today, the consumer printer, what you see here, is becoming a great learning tool. Every designer, R&D guy, or group of students can have a small place in the college and work on many things. And there are many small machines available today, which are good, quite good. No compromise on quality. And, so more and more institutes are now coming out with. Sorry, there is a sound coming from the metro construction. And so you have, you know, people can have a maker place. Atal tinkering lab is there. They can also provide. They also have 3D printers, one of the hardware available always. So it helps in elevating the community, societal, maker culture. You know, build a maker culture. That is very important. And you can see such a big 3D printer available. You'll have remote inside. No need to get inside. Everything is done on its own. And we have the future 3D factories to look like this. No oil. It's all clean, and you have people are able to manage just one or two people can manage the entire factory. So that's the thing. The beauty of this technology comes from its capabilities. So many things can be built as one. This is called as part consolidation. Means there is no bolts and nuts. There is no hinge. Everything is built as one. It works like a normal box and a hole, but the part count is just one. And we can do a lot of jigs and fixtures using this. We can do very complex parts using this technology. And we can also help in making the batch production using a silicon mold, or use it as a pattern for metal printing, metal casting and all. You can print a mold. In fact, people have tried printing very big things. So this is the parts of castle where they used material as a concrete, a special mixed concrete that is deposited. You can see the layer by layer. Very characteristic of 3D printing. You see the layers, scales, and when it was put together, it was looking like this. Right? So these are some of the demonstrations. Not that they are all viable. Viability to come in future, but right now, capability-wise, it is possible to print big things. It is also possible to print small things like this one. This is IIT Kharagpur's main building, and you can see this is printed in a nanoscribe. Now you can see here there is a small little 20 micrometer green scale is there. You can see, and that is 20 micrometer. So as well, some of these windows, vertical lines and all, will be a micron or less. Okay. So where do we use it? So people are increasingly using it in micro mechanical devices, MEMS, and also making robots and many such applications, wherein they'll be able to do such very small things. The future of manufacturing itself, you can think of microscopic things and megascopic things, both will be. In fact, because of the capability of this technology, you have new aesthetics that is today possible. You can see this. It's all not possible to do by any other process but by 3D because they are so complex, and it is not possible to do any other way but by 3D. You can see shoe, the eyewear, bag. You can see the jewelry is not a piece of metal. It's a fun. You can freak out with designs like this. You know, that tomorrow's habitats will look like this. By scanning and taking furniture and animal can be combined together. Makes such interesting things. And you can see the very characteristic of this is influencing the way jewelry is. You can see these are truly unimaginable. It's hard to even imagine them. And you can see some of these fluidity flow like a cloth possible by 3D printing. So 3D printing means they come in all shapes and sizes, different. They're all capable, but they come in forms like this. Each one is good at a particular task, and so we have a palette. If you reach Imaginarium, you reach the world of and the future is about all going beyond prototyping and end user parts. So like what? Like you have this metal part is built by metal and plastic part, and this is done by 3D. So there could be a lot of such things in future. So this is end
engines.
user part goes on one engine, and it's very complex, and this is also a very complex part. Likewise, there are many such capabilities. It not only looks good but works good, and it is going to endure the life cycle. And so, one big advantage of 3D printing is the complexity. It can handle any type of complexity on one side. And one big disadvantage is there is no economy of scale, meaning I cannot make a thousand number, 10,000 number, 1 lakh, so I can reduce the cost. All of them, more or less, will cost the same. That is one disadvantage. And in medical, of course, there are 5 levels, as you can see here. 3D printing can help. One is making devices, then you have anatomical models. At third level, you make guides and fixtures for surgery. And fourth level, you can make implants. And fifth level, becoming God, printing bio uh, organs or biomaterial or such things. People at 4 levels have achieved very successfully. The fifth one, God is playing hide and seek, and so people all over the world, probably including in UPES, they'll be doing research on this. Well, coming to the complete spectrum of subject today, you cannot print anything. The printing is in the middle, circled in red. Okay, but you can see on the right side and left side, there are many things. First thing is idea. If you don't have idea, you cannot print anything. What is that you're going to print? One day you print something, okay. Next day you're going to print same thing, no. So a printer is used to solve some problem, solve it. So after having that idea generated, then the idea cannot be again converted. So idea has to be converted to be a content, 3D content. So for that you require CAD. And then of course that CAD cannot be directly given to the printer, speaks a different language. So you have to translate, so it's called pre-processing, okay, where you convert the CAD format to a 3D printable format. And that is done, that is given to 3D printing. 3D printer prints, and 3D printer needs material on the top, and of course it requires a lot of love and care, otherwise it will not work with those patterns. Just like a creative kit, 3D printer is like a creative kit. If you don't take care, it will not operate. Then of course you have post processing. You see there is a characteristic line which is there, particles or anything, objects that has to be smoothened. You can paint it, you can plate it, you can do lot of other things, mission it and all. And then what you have is a world of application where you can apply. It's only your imagination is the only one. Think anything, think beyond. The sky is down the limit. See. And of course, I've written here DFAM, that is designed for additive manufacturing. It's re-engineering, re-engineering for reverse
DFAM
engineering,
designed for additive
scanning
manufacturing.
that best also. Well, that shows the spectrum of 3D printing what we have. I come to an end of today's presentation. Just I would like to invite your questions now. In case you have any questions, I would like to take. I'm sure this have made it very light because your exposure to technology is less. Probably this will become a good trigger for all of you, young minds to think about and probably select area wherein you can contribute. So if you go back here, uh, this shows some kind of a scope where people can study what. The first one is about design. Designing is very important, and the CAD is a big world by itself. You know, CAD not necessarily mean designing because CAD is a translation of idea into embodiment. And again, pre-processing export also is probably a lower level function, but very important, without which you cannot. So the people who design 3D printers, maintain 3D printers, take care of their maintenance and all, and also a kind of so a lot of hunar, so the skills required, and this will initiate such study material. Real world is real material, and all of us are in real world. So material research is also very important. And application is great area. Medical, aerospace, automotive, jewelry. And when you are in Mumbai, don't forget to visit it. We take each one of you. When you visit, there is nothing to be asked. You want to do, see the facility, somebody will take you, volunteer will take you around. Okay? Because seeing is bigger, not everything. There was a movie I wanted to show. We have a movie. Shall I share a movie now?
Meanwhile, students, we open the chat for the question answer. If you are having some questions, you can type in the chat box.
Okay, so
Sir, kindly share that slide on e-certification.
oh, sir, sorry, I will not that you can announce it because I was looking for a slide. I was too busy because I immediately after this I have 4 o'clock. I have another talk,
Okay. So,
so I could
uh,
not insert it. Sorry.
so there are some instructions for the students for the e-certification. First of all, the student should log in on Zoom only with the names he wants on the certificates. Second, the email ID of login should be the same as used in the registration form. Third, complaint attendance on all days is must. So, do you have some assignments for the student? Do you want to
Uh,
give assignments?
Well, I don't think I will give any assignment because I'm not sure whether I have access to 3D printer or not. Probably they can make a
Okay,
they can try to make a pot using layers. You have a thick cardboard, 2 ply, 3 ply, 4 ply like that. They can start cutting, make a spear like chota circle, then thoda bada circle, और बड़ा और बड़ा, then diameter तक जाएगा, then you need to again do the reverse of it, छोटा 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 छोटा. So you have a uh, additively made spear. So if you want to, you can make it and submit it. It need not be only a spear. It can be a cylinder. It can be a pyramid.